how to use Jupyter Labs and Jupyter Notebooks. In this recording, I will assume that you have an Anaconda environment set up with Jupyter installed, and I will also assume that you know how to open up a Jupyter Lab or a Jupyter Notebook server. If you do not know how to do this, I have separate videos that are linked in the description that will give you step-by-step instructions on how to set up your Anaconda environment and how to start a Jupyter server. Now, I will go over 4 main elements of Jupyter Labs and, to an extension, Jupyter Notebooks. The first one is I will show you how you can open up a notebook or a file or terminal window within the Jupyter Notebook system. I will guide you through how to use a Jupyter Notebook by giving you common keyboard shortcuts, but also showing you a couple tips and tricks on how you can make the best out of a Jupyter Notebook. I will show you how you can create different views, different tabs within Jupyter Labs so that you can open up multiple things at the same time. And finally, I will talk a little bit about Jupyter Lab extensions, and I will show you the tab where you can find the information in order to get that set up. Now, you can use Jupyter Labs to open up a wide variety of file types. Most notably, by default, you can use it to open up notebooks, Jupyter Notebooks. In my case, I only have a Python kernel installed, but you can use this for different kernels as well if you have those set up. In my case, I have a Python kernel here, so I can open up a Python notebook. I can open up a console window. I can open up a terminal window. I can open up a regular text file. I can open up a Markdown file, or I can open up the help. So what I'll show you is I'll show you 3 different types. I'll show you how to open up a Jupyter Notebook. I'll show you a terminal window, and I will also show you how you can open up a Markdown file. So the way you do this, you click the plus icon here. That will open up the launcher. The launcher will give you the variety of different things that you can open. In this case, let's say that we would like to open up a Jupyter Notebook. So we click Python 3. We can now see on the left here that we are currently on the File Explorer tab, as indicated by this folder icon. And here we will see for our current directory, which is listed up here as a demonstration, that we've now created a new Jupyter Notebook file that is called Untitled. We can right-click that file in the File Explorer window right here, and we have a variety of different options that we can use in order to manipulate this file. For example, we can click Rename, and let's call this Demonstration. And now you can see that it's reflected here that we now have renamed to this Jupyter Notebook file to be Demonstration, and it also shows up here in our different tabs that it's now called Demonstration. Now these tabs up here you can use to either navigate to different notebooks, but this can be a wide variety of file types. For example, you can have Markdown files open, you can have a notebook open, you can have terminal windows open, the help file, or whatever you would like, you can kind of put up here. Now, for example, we could also decide that we would like to open up a Markdown file. So we can go back to that plus, go back to the launcher, and then we click Markdown. And now we have a Markdown file right here. So if I were to type something such as this, then what I now have created is I've created a .md Markdown file. A key kind of use of the Jupyter Labs would be that you say, well, I now currently see the code view of Markdown, but what if I also would like to create a preview, something that has all of these formats rendered? And I can right-click in this editor window and click Show Markdown Preview. And this will do 2 things. One, it has now opened up a preview window. And as you can see, here's the code representation. Here is the formatted representation. So that's one thing. It has created a separate tab for us that has that preview window. But it has also split up the views for us here. And it has done that automatically because it realized that if we want to see a preview, that we would probably like to see that side to side with the code. So right here, if I were to add a new title, for example, and click Save, and I saved by clicking Ctrl S, then you can see that that is now automatically reflected in the Markdown window. Now this is very useful because, for example, if you want to keep notes, you can just keep that Markdown file open here, a README file or some other Markdown file. Or if you're creating documentation or you're creating some notes for your own use, then having this open can be very useful. As you can see here, I can click the tabs and I go back to our notebook file. And now in this case, we would have the notebook file on the left and the preview on the right. But if I wanted to have, for example, the notebook file right here, But I would also like to have the ability to edit the Markdown file while still maintaining the ability to see the preview. Then what I could do is I could go to the tab that I would like to move, and then I drag it, and then I can drag it anywhere I want. And as you can see, that blue icon or that blue area appears that will indicate where it would end up if I were to let go. So let's say that we would like to have that at the bottom right here. I could click here, and as you can see, I would now have my notebook on the left, I would have my Markdown preview on the top right, and I would have my Markdown file that I can edit at the bottom right. And this is all still dynamically linked, because as you can see, if I edit this Markdown file, it will still show up in the preview. We can do the same thing when it comes to Jupyter notebooks, and more specifically, we can do the same thing with an underlying terminal window that we can use to interact with the same kernel that is currently executing commands for the Jupyter notebook. The way we can do this is by right-clicking in the Jupyter notebook, just like we did with the Markdown file, but then in this case, we are going to click New Console for Notebook. This is going to open up an additional window that we can now use to interact with the kernel that is also running the Jupyter notebook. So for example, if you've never used a Jupyter notebook before, a Jupyter notebook is essentially a way for you to interact with the Python kernel. It's a more powerful Python file, if you will, that enables you to run code, and that code gets interactively executed as you're working in your notebook. But it also allows you to add Markdown formatting or any other formatting in order to provide comments or detailed instructions as to how your code is running. So for example, let's say that we would like to print a simple message in our Jupyter notebook. If we know how to do this in Python, we can execute the Python code. So it would say print test. Now what we can do if we want to run this is we can click run the selected cell in advance, which would be this arrow icon right here. Now as you can see, this has now executed this print command, and it shows you the output below that particular cell. This is the core functionality of a Jupyter notebook. Now alternatively, what you can do is you can create a bunch of different cells, and I created these by just clicking the shortcut B. You can also click the plus icon, which will also create cells. If you click B, it will create a new cell below. If you click A, it will create a new cell above, which is hard to see in this case. But you see here, I created a new cell above when I click A. If we were to create a variable, let's say that we would create a variable called test. And we would add a string and assign it to the variable. If I were to run it, and generally I like to run the cells by clicking Control if you're on Windows and Enter. Control Enter will run the cell, but it will not automatically switch to the next cell. You can do that using a different keyboard shortcut or by clicking this arrow icon, but personally I'd like to stay in the cell that I'm currently working on. So you would do this, it will run, and as you can see here, anytime a cell has not seen any code being executed in it, it will not have a number in the square brackets in front of it. In this case, you can see that it says square brackets 2, which indicates that it has executed the code, and we now know that that is working. So we've executed this, and just to wrap up so that I can close the terminal window here, because the underlying Python kernel is linked between this notebook and this terminal window here, if I were to now call this variable that I created in my notebook called test, I can call that from my terminal window, and you can run this by clicking Shift Enter. You can now see that I've been able to pull up the test variable, and it was able to retrieve that variable contained a string called message. This is useful if you want to interactively try to look up what variables are, or if you interactively want to test some code, but you don't necessarily want to do it directly in the notebook. You can just have both of these open. The only thing worth noting here is that anything you do in the notebook file, you can save that and it will be there. Anything you do in the terminal window, as soon as you close the terminal window, it will be gone. So it's just for kind of testing, looking up things. So I will, for the sake of focusing on the Jupyter notebook, I will just close out this terminal window, and I'd simply do that by clicking the X icon on that particular tab. And I can also do the same thing for all of these windows. And then I would like to make two main comments here with regards to Jupyter Lab, and then we'll transition primarily into how to use the Jupyter Notebook specifically, which is that one, anytime you do something in a notebook, but you haven't saved it yet, it will show up right here using this grayed out circle. That grayed out circle indicates to us, and it's exactly where the close cross would be, it indicates to us that we have not yet saved the most recent changes that we made to this file. And this also applies to Jupyter Notebook files or Markdown files. For example, here, if I were to quickly change this, you can see here that we also now have an icon here. Now, as soon as I were to save this Jupyter Notebook, and I can save it either by clicking that floppy disk icon or by clicking Ctrl S, just like you would do in many other pieces of software, then it will save. And then also that gray circle here will disappear. And that will indicate to us that we've saved our notebook. And if we were to now close it, then there's no risk of losing what we did. So you kind of want to keep an eye out for that. Whenever you see these circles right here, you know that, hey, you probably still need to save it. Otherwise, you might lose some work. And if you were to save a file that is not yet saved, you will get a warning message to say, hey, you have unsaved changes. Are you sure that you would like to close this without saving? In this case, I didn't make any important changes, so I can click yes. The way I just closed these windows out is you can also click your middle mouse button and then you click it down. You don't scroll, but you click on your scroll wheel. That will also close out the tab. The second thing that I would like to show you is the fact that there is an other circle right here. And this circle is specific to Jupyter Notebooks. And this circle will indicate to you whether the current Python kernel is busy. Busy means whether it's running code and whether it's being occupied by that code that's being executed. Now, this is important to know because as long as that icon is grayed out, that means the Python kernel is busy and you cannot execute any other code. So for example, if I were to just import the time library in Python just so that I can artificially make the kernel busy for a little while. So I import time, I just run the code, I type it in, I press Ctrl Enter to execute the cell. You can see here that there's a number 4, which means that that is executed. And now I can refer this time package in any of these other cells. These cells all share the same Python kernel. So it doesn't matter what cell I'm particularly using because they're all sharing the same Python kernel. So in this case, I can go to a second cell and I can say time sleep. And in case you're unfamiliar with this command, this will make it so that the kernel will sleep for a predetermined amount of seconds. So I can say, okay, sleep for 10 seconds. And then again, I will press Ctrl Enter. And now it's running for 10 seconds. But notice here that now this circle is grayed out, which means that the kernel is currently busy. We can also see here that we now have an asterisk in that square brackets. So now after 10 seconds, the code has finished executing. This circle now becomes white again, which means that it's available. The kernel is no longer busy. And then if I were to run it again, you can see here, there's an asterisk here, which indicates that this particular cell is running. And here we know in general that the current Python kernel is busy because it's grayed out. So those are two main indicators that you should keep track of, whether your notebook currently has unsaved changes and whether your Python kernel is currently busy. We now know kind of the logistics of using Jupyter Notebooks in Jupyter Lab. But how would I go about using Jupyter Notebooks for an actual piece of code, for an actual project? A couple core things about the way a Jupyter Notebook works. A Jupyter Notebook works by having cells. And every cell will contain a piece of code or a piece of, call it non-code. Generally, that will be Markdown or some other piece of text that will not actually run any code, but is just there to provide additional information about the code that you're running. So that means that we have two main categories of cells. We can have a cell that has code in it. I will just refer to that as a code cell. And we can have code that just has text in it. And I will refer to that as the Markdown cell. The way that we can distinguish these two types of cells is a code cell will have these square brackets in front of it. That means that it's executable. You can actually run it and it will send code to the Python kernel and that code will get executed. Now, what you can do is whenever you select a cell, and you can tell that you have a cell selected if it shows this, this blue indicator in front of it, then if you have that cell selected, you go up here you click on this little drop-down menu, you can see the different types of cells. You don't need to worry about what a raw cell is, but no, we have a code cell and we have a markdown cell. If I click a markdown, then notice two things. First, it still looks like any other cell, right? I still have a cell, I can select it, but I no longer have these square brackets in front of it. And that means that I can put code in here, or sorry, I can put text in here, and I can execute it, and I can execute it just like a regular code cell. In this case, I press Ctrl Enter. But notice that it has now not executed whatever is in that cell, but instead it has just kind of rendered it into something that looks nice. So in this case, I just put some text, I clicked Ctrl Enter, and I now just see some text here that can provide some additional information about the code. Now, because these are markdown cells, I can also apply markdown formatting to these cells. Because, for example, if I wanted to create a title, I could do the following. And then I click Ctrl Enter, and now it knows, because of the fact that there's these kind of fence symbols in front of it, then it knows that this needs to be a title. If I do a single one of these, it's going to be larger. And I can put a couple here. And you can see that I now have a large title, a slightly smaller subtitle, and then an even smaller title. And I can also include, for example, code examples. And this is all just standard Markdown formatting. So if you're not familiar with this, you can just look that up. And if I run this, then you can see here that this is still a Markdown cell, right? There's no square bracket or number in front of it, but it just looks like Python code because I actually just created a printed version, a visual version, not an actual code execution, but just a visual version. And this can be useful, for example, if you have a piece of code that you would like to save, but you don't want to run it by accident, so you can just temporarily put it in the Markdown cell, have it there, you can select it, you can read it, but it's not actually going to get executed. Two additional things that I would like to share with you about different types of cells is that one, generally easiest if you switch between cell types by using the provided keyboard shortcuts. There's two of my main ones that are worth remembering, which is if you press Y while selecting a cell, it will convert it into a code cell. So as you can see, now it's a code cell because I see the brackets, and we can convert it back into a markdown cell by pressing M. And the second piece of information is that you will notice that if I am currently in editing mode of the cell, then whenever I press these keyboard shortcuts like Y or M, it's just going to put that in the cell. It's not actually going to change the type. The way that you have to change types is by either clicking here on the white part, and then you can tell that you've now entered what they call command mode, which is the way that you would change cells instead of changing something inside of a cell, would be that here at the bottom, it will tell you that you're now in command mode. When we are inside the cell and we're editing the cell, it will tell us that it's currently in editing mode. So it can be in command mode by left clicking here, and then we can change things about the cell, such as changing it into a code cell, changing it into a markdown cell by using the keyboard shortcuts. But we're in command mode, and then if we go back into the cell, we'll go into edit mode, and whenever we press those, we're just going to send those inputs into the cell. An alternative way that you can quickly switch into command mode is just by clicking escape. So if you press escape on your keyboard, it will also move you into command mode, and now we can just use our keyboard commands in order to switch between different types of cells. And then if you want to go back into edit mode while you're on a cell, you can just press enter, and that will move you into the editing mode for that particular cell. So enter in order to go into edit mode, and escape in order to go out of edit mode into command mode. If you're in command mode, you can also manipulate cells. So you can create new cells like I just demonstrated to you. For example, by clicking B to create new cells below it, or A to create new cells above it. But I have to be in command mode in order to do this. And also, I can simply use my mouse to drag cells to a different position. So let's say that I would like to have this cell with the import statement. I would like to have that first. I can just drag that up here, and now I've changed the cell. Now I can also do this for multiple cells at once, because if I press down Shift and then I click, like let's say I have this top cell selected and I hold Shift and then I click this cell, then it will select all of the cells that are kind of from that first cell I selected to the cell I clicked on. So in this case, I now have 3 cells selected. And then again, I can use that same drag logic to drag all of these cells to a different position. You can also delete cells. Generally speaking, the way that I prefer to do it is by using the cut feature. And you can either use the scissors. For example, here, if I select this cell and then I press the scissor, then it will disappear. But you can also use the shortcut by clicking X. Now, one thing that you just saw me do here is that you can also undo these things. So if you, for example, make a mistake and you by accident delete a cell that you did not want to delete, you can press Z, think Ctrl Z like you would do in any other software in order to get back. But you have to be in command mode and you don't need to press Control. You just press Z in order to do that. So if I were to delete this, I can press X, which is cut. So I can also copy it back, and I can copy by clicking V from Ctrl V, but then without a control, and I need to be in command mode. Or I can press Z in order to undo what I just did. I can also copy paste cells by using C and V. So if I'm in command mode, I select a cell and I press C and then I press V. I will now have a copy of that particular cell. This can also apply if you have multiple cells selected using Shift. I press C, I press V, and as you can see here, I now have multiple of these cells selected. And then if I want to delete these, I can just select the ones I want to get rid of. And I press X in order to get rid of them, and then we're good to go. So that is generally how you would set up your code file. You would have some Markdown files where you would provide your additional information, titles, links, whatever you want to do. And then you would have your code cells that are actually running your code. Now, it might be that at some point your code gets stuck. And if your code gets stuck, you have two options. You can either try to interrupt the current kernel and essentially make it available again. So for example, let's say that I have this sleep command running and I decide, well, I don't want to wait another 15 seconds for this to finish. What I can do is I can click this interrupt kernel square icon. So I were to click this, and sometimes it takes a little while. So in this case, you can tell I clicked it, but it just took a little while for that keyboard interrupt to go through. If I were to do something like this, then the interrupt tends to be a little bit more reliable. Now, if you get in a situation where interrupting it doesn't work, and maybe your entire notebook is freezed up and it's not currently working anymore, what you can also do is you can reset or restart the entire kernel. Restarting the entire kernel you can do by clicking this little circular arrow icon. You can do this, and this will, in nearly all cases, restart everything and you'll start over fresh. The only thing is that anything that you've saved in memory is going to be gone. So for example, let's say I create a variable and I put my name in it and I run this. And now if I were to run this, then you can see that I have that variable there and I can use it, I can call it, and it will all work just fine. If I were to click the restart kernel button, then it will tell me, well, are you sure you want to do this? Because all variables will be lost. If I say, okay, sure, and I click restart, then if I now try to refer to this temp variable, it's going to say, well, the variable temp does not exist. And the reason for that is simple, is because I restarted the kernel, which means that this temp variable got reset, got refreshed, and I will have to assign it again in order to get all of that running. Now, one thing that is useful if you were to do this, or if you kind of were to continue working on a file after you've saved it and then you came back the next day, for example, is that sometimes you would like to run all the code up to some point. You have a wide variety of options that you can use in order to do this. You can go to run in the top here, and this will give you a variety of different options. The one that I use quite often is the run all above selected cell, which means that if I'm, for example, in this cell right here, and you can tell I'm here because of the blue, I click run, and then I click run all above selected cell. That will then run all the cells in order from top to bottom that are above this particular cell. But it will not run this cell and will not run any of the cells below it. So if I was working on some code and I want to make sure that I have everything up to date again, I can just go to where I was kind of working on, select that cell, click run, and then click this one, and then I will be back to where I was. And if I now want to run temp, I will have it again because it re-executed that code. Another one that can be useful is the run all cells option, which will run all the cells in the notebook. So if I were to click that, then it will just run all the possible cells. It will execute everything. Now, one advanced feature of Jupyter Notebooks that I will not spend too much time talking about, but that is useful for you to be aware that those exist, are a feature of IPython, which is the thing that's underlying the interactive way of interacting with your Python code, has the ability to do what they call either cell magic or line magic. Now, cell magic means that you can add a certain command or certain features to a particular cell in order to beef up what it can do. For example, if you want to know how long a particular cell takes to complete, you can use the time cell magic that comes automatically with IPython, which you automatically have if you have Jupyter set up. And you can do that by calling for the cell magic, which you do by doing $% at the beginning of the cell. So I do $%, and then I would put whatever feature or command I would like to kind of assign to that cell. So in this case, if I were to put % time and I were to run this, then it will execute the cell as normal. But after it's done, in this case, it will take about 10 seconds for that to complete. It will also tell us how long that cell took to run. So because I specified this, it will kind of start a counter as soon as I start it, and it will print out here at the bottom that it says the wall time, which means how long it was running, was 10 seconds. This can be super useful if you try to get a sense of how long it takes for your code to execute. There are alternative ways to do that for a loop. For example, one feature that I like to use is to use the TQDM feature, which you will have to install, but if you use one of my environments, you will already have that. You can import it as such. And then if we have this loop, we can wrap this in TQDM. And now we will get a progress indicator that can also substitute for that time cell magic. If you Google IPython and then you Google magics, you will find this particular documentation right here. And this has all the different built-in magic commands that you might want to be able to put into your notebooks. They're all here. If you want to look that up, you can look that up. I'll put the link right here. There you go. Now, the final thing that I want to show you is that there is a whole bunch of features in JupyterLab that I have not yet showed you. But just to show you one particular thing is that one, you do have these little tabs here at the side. You have the main file explorer tab. That's the one you'll be using most of the time. You also have an overview of all the running kernels. You can use this if you want to shut down a kernel completely. You can go in here, you can click shutdown. You have a search bar that you can use to find all the different commands that are currently in Jupyter. So if you cannot find something, you can go here into the commands tab. You have a property inspector that's not super useful. You have open tabs. In case you have a lot of them open, you can have a little bit of a better overview here. And then finally, the tab that I do want to talk about is the extension manager. Now, if you open up JupyterLab for the first time after setting it up, you might have to go in here and you might have to click a red button that says activate extensions or something along those lines. That's a security barrier to make sure that you deliberately enable the functionality of extensions. But extensions can be super useful in order to get additional functionality into Jupyter Labs. There's a whole variety of them. Some of them come by default, as you can see all here. But if you go and look on GitHub, you might find a couple of different ones as well that might be useful. Right now, for the environment file that I provide, I generally give you the QGrid one so that you can interactively interact with pandas data frames. And I have the Plotly JupyterLab widget so that you can create easy interactive visualizations. But just know that whenever you need to interact with the JupyterLab extension, you can go into this tab and then you can uninstall or install different ones and you can disable them. So whenever you run into any of that stuff, go into that tab and then make sure that it's all set up appropriately. And that is everything that you need to know in order to get started with JupyterLab and Jupyter Notebooks.